This video is for adding and subtracting fractions. My first problem, my example problem, is 3/4 plus 4/5. Here's what the problem looks like visually. 3 out of 4 possible parts, and I'm adding 4 out of 5 possible parts. Now it looks like this is going to be more than 1. The answer is going to be more than 1. So, I know I need common denominators. Now one way I can always get common denominators is by multiplying the two denominators together. So 5 times 4, that gives me 20. I can make my 3/4 here an equivalent fraction out of 20. So instead of 4 parts, I would make 20 parts. 4 times 5 gives me 20. So I have to multiply my 3 also times 5. 3 times 5, that gives me 15. I hope this is looking familiar to you because this is proportional. 20 times 3 gives me 60. 15 times 4 also gives me 60. So this fraction is equivalent to 3/4. To get an equivalent fraction for 4/5, I know my denominator will be 20, so I'm taking 5 times 4 gives me 20, and 4 also times 4 gives me 16. These are equivalent fractions. 4/5 is the same as 16/20. 3/4 is the same as 15/20. Now visually, here's what it looks like. 3/4 and 4/5. I'm going to change 3/4 here. I'm going to change my denominator to 20ths. So I've now got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 20ths. And 16 20ths. So just looking at these, I can see that I've got 15, another 15. This is going to be 31 20ths when I add these together. That's an improper fraction. 31 20ths looks like this. 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1 and 11 20ths. Going back to this problem, 15 20ths plus 16 20ths equals 31 20ths. So I know that I have one group of 20 in 31 and a remainder of 11. My answer would be 1 and 11 20ths when I add these together, because 20 times 1, so there's 20 20ths here, and another 11 20ths gives me 31 20ths. My next example problem is a subtraction problem. 7/8 minus 1/6. This is what it looks like. 7/8 taken away 1/6. You can see here that the denominators are not the same. So I need to find a common denominator, so I know how big my fraction will be in equal parts. So the way I can do this, I could multiply these two numbers together. I could take 8 times 6 gives me 48. That will definitely work. I could convert this into 48ths and find an equivalent fraction here that's in 48ths. But there's a more eloquent way, or more efficient way. I can look for the least common multiple of both of these numbers. Least common multiple. So what multiple do they share? So all I do is I find, or I can write this out, or I can just think about it. What are multiples? What's the smallest multiple that both of these share? When I say multiple, I'm saying 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. And 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. There it is. The least common multiple. The smallest multiple that each number shares. So what that means is I can take 7/8 and find an equivalent fraction that's in 24ths. This will be the smallest common denominator that these two numbers have. And 1/6 I can find an equivalent fraction in 24ths. Now I should point out that all my shorthand work over here, showing you the equivalent fractions, this is not a mathematically accurate sentence. You can't have two equal signs in a math sentence. I'm just showing you the equivalent fractions, kind of like they're like separate things. These are like my thought bubbles here. So 8 times what gives me 24? Well, I can see here that it's 8 times 3. So 7 times 3 gives me 21. And 6, 24 is 6 times 4. So that means I've got to take 1 and also multiply it by 4. That would be 4 24ths. So now I have two equivalent fractions with common denominators. I can look at that and see that 21 24ths minus 4 24ths gives me 17 24ths. And here's what that looks like. Here's my 7/8. I'm going to make that into 24ths. And my 1/6, I'm going to make that into 24ths. And now you can see that my denominators, they line up. So I take these 21 24ths and I subtract these 4 24ths, and I'm left with 17 24ths.